Hi everyone, my name is Kunal Rajendra Patil and I'm a fourth year BE student at Blynk College of Engineering and Technology. Today, I'm going to walk you through a project which I built while I was interning at Emertxe Technologies and Private Limited, Bangalore. The topic of the internship was IoT or Internet of Things, and the duration of the internship was around 1 month. Okay, let's walk you through the project. The topic of the project is IoT-based home automation solution. Let's delve into the presentation, and later I'm going to show you the working of the project as well. First, let us go through the contents of the presentation. Uh, Here are the contents, which include C programming, IoT, embedded systems, project requirements, schematic diagrams, garden light control, temperature system control, water tank management, project screenshots, conclusion. All right, let's dive into it. Firstly, I'll just briefly explain you what are the topics which we learned in what are the few things which we learned in the internship. Firstly, before starting out the project, Ms. Jayalakshmi ma'am, who was our mentor, taught us a C language, and the main topics which are covered in the C language were data types, which include char, int, float, double, etc., and modifiers and qualifier, conditionals and loops, operators, arrays and pointers, strings, functions, storage classes, key processor, etc. Alright, moving on. Let's first understand what do you mean by IoT? Well, firstly, IoT or the Internet of Things refers to a network of interconnected devices that communicate and exchange data over the Internet. These devices, embedded with sensors and software, enable remote monitoring and automation of various systems. By means of low cost computing, the cloud, big data analytics, and mobile technologies, physical things can share and collect data with minimal human intervention. In this hyper-connected world, digital systems can record, monitor, and adjust each interaction between connected things. The physical world meets the digital world and they cooperate. Here is a basic working of the Internet of Things. Alright, so this is the basic architecture of IoT. Moving on, we also learned a bit about embedded systems during our internship at Emertxe Technologies. All right, what is an embedded system? An embedded system is a specialized computing system designed to perform dedicated functions within a large mechanical or electrical system, often with real-time computing constraints. These systems are integral to devices, providing control, monitoring, and processing capabilities. Embedded devices have peripherals such as serial communication interface, synchronous serial communication interface, universal serial bus, multimedia cards such as SD cards, compact flashes, etc. Alright, moving on. Here is a basic block diagram of an embedded system. Alright, now I'll give you the overview or the scope of the project so that you would understand what the project is all about. Purpose of the project. Well, the purpose of the project was to develop a simulated home automation system that allows control over household devices like lights, heaters, and water valves through an IoT-based mobile application. Scope of the project: simulation environment. For simulating the environment, since this was a virtual internship, for simulating the environment, we use Pixel Labs software to emulate the real-world hardware setups. Remote control. We employed Blynk IoT mobile application to manage devices such as the lighting system, temperature regulation, and water tank levels. And real-time monitoring, for monitoring the devices, we use both CLCD display and the mobile application. All right. Here are the hardware and the software requirements for the project. Hardware requirements include basically an Arduino Uno, Ethernet W5500 module, temperature system which includes both heater and cooler, a CLCD display, an LDR sensor, and LEDs. Software requirements include Arduino IDE, which will be used to code and generate the hex file and the binary file, which will be then used and fed up into the Arduino Uno. PiximLab will be used for simulating the environment, real-world hardware on our PC. Blynk IoT app. What is a Blynk IoT app? Blynk IoT app is basically a cloud server and a mobile application which will allow us users to control the appliances right from our phones. Virtual serial port tools, which will be used to generate a local bridge between the serial tank and the Arduino Uno. and a serial remote tag which will be used for simulating the water flow, water inflow and outflow in a tank. All right, moving on. Here is a basic schematic diagram of how things are going to work in this project. As you can see from the Blynk app, if a user sends a command, if a user wishes, for example, that the heater to be turned on, the user would press the button for the heater to be turned on. This command would be sent onto a Blynk cloud server, wherein the heater would have a specific virtual pin assigned to it, and now after receiving the command from the user, the Blynk cloud server will send that command to the Arduino Uno, which would then perform the execute for execute the send the information to the required embedded system to execute the action. All right, moving on. The first thing which we are going to show you in the project is basically garden lights control. What is included in this project? Firstly, what requirements are of this project? Firstly, the system should be able to read the LDR sensor value, and based on the reading from the LDR, vary the brightness of LED, which resembles controlling the garden lights based on the availability of the sunlight. Moving on, the next thing which I would like to show you in the project is the temperature control system. In this, the temperature control system consists of a heating resistor, an LM35 temperature sensor, and a cooler, which resembles the temperature control system at home. By reading the temperature from the temperature sensor value 35 and display it on the CLCD display, controlling the temperature of the system by turning on or off the heater and cooler through the Blynk IoT mobile application. This is basically the description of the second project. And the third thing, which is included, is the water tank management. Now, the description of the system is basically that it should read the volume of the water in the tank through serial communication and display it on the CLCD, and control the volume of the water in the tank by controlling the inlet and the outlet valve by sending commands through serial communication, and by displaying the volume of the water in the tank on CLCD. These are basically what the project requirements are and how the project should perform. And this is basically the description of the system that, and based on it, the project should be built. All right. So this is basically the simulation or image of the project which I have built, and I'll show you the working of the project in the later part of the video. All right, moving on. These are basically the screenshots which I've included in the presentation, so that you get a basic idea as to what the project is all about. Here, as you can see, the LDR is high. In the image, you can see the LDR value is high, so the LED is glowing, whereas in the bottom picture, the LDR is low, so the LED is off. Similarly, as you can see in the CLCD display, the cooler or display is showing because the cooler is turned on through the Blynk IoT application, and in the bottom one, the cooler image, the cooler of display is displayed on the CLCD screen. All right. Similarly, goes for the heater, inlet valve, and outlet valve as well. All right. Thank you. And I would like to conclude that I have successfully developed an IoT-based home automation system using Arduino, Pixel and Blynk, offering efficient and remote control over home lighting, temperature, and water management. That's it from my side, and I hope you have got a basic idea about what the project is all about. And let's get to the working of the project. All right. So moving on, now I'll explain the code a little bit, and then we'll move on to the working of the project. As you can see, this is the Arduino IDE version 2.3.2, and the board which we are using for the project is Arduino Uno, which we have selected it here. Now this is the code. Now I would like to point out specifically, as seen in the code line number 9, you can see there's a Blynk authorization token and some few gibberish words written here. Now, these gibberish words are basically a unique identification token or authorization token which is generated when we log in and sign up in the Blynk IoT cloud application. But now, as we know, we have used a Blynk application for this project. Why have we used it? Firstly, the main function of IoT is that it basically enables smart devices to be controlled by our electronic devices, so that we can control them using basically our smartphones. So how would basically the devices know that we have sent a command to them and they can act upon it? So for this project, we have downloaded Blynk IoT application from the Play Store in our phones, and we have configured some buttons and set up some virtual pins for each and every button. Now, the buttons, when we press it, how will the sensor, or how will the lights as well as the inlet walls know that we have pressed the button and we wish that the following command to be executed? For this, we'll create a Blynk Cloud application. In that Blynk Cloud, we will configure the same virtual pins which we have selected in this Blynk phone application, and we will link both of them together. So what will happen is, when we press a button in our phone, uh, let's say saying that we want to turn on the cooler. So what happens is that after pressing the button here, the virtual Blynk cloud will send the message to the Arduino Uno board, which will then further execute the instruction and then lead to the cooler being turned on, as I'll show you further down in the video. So basically, this is the code for it. You can see here are certain libraries which you need to install for the project to work, which is basically the Ethernet libraries, Blink Simple Ethernet, Liquid Crystal I2C library, which is a major important library. Now, uh, first, there are certain other. We have also shown some other header files as well, and I'll get to it later. Uh, this is the complete code, and as you can see, I have included the comment as to what the particular segment of the code does. This segment of the code is used to handle the cooler controls. Okay, for moving on, this segment is used to handle the heater controls. This segment for the moving on, this segment handles the inlet valve control, outlet valve control, right? And Uh, we have also shown some temperature reading controls, in which temperature reading controls wherein if the temperature rises below 35 degree and the heater is on, then the heater is automatically turned off. So the maximum range to which the temperature can go in this project is 35 degrees Celsius. All right, and similarly, if the tank volume is less than 2000 and the inlet valve is on, then it shows that the inflow is on. Inflow is on. And if the tank volume is greater than or equal to 3000 liters, then what? And the inlet valve is on. So what happens? That automatically the inlet valve turns off, since that's the maximum limit that the serial tank can handle. This is basically all the other libraries which we have initialized. Okay, and, this is the LDR CPP code which is used to initialize the brightness of the LED, which I'll show you further down in the video. This is the header file for the LDR sensor. These are the main files, main header file. Now, one thing I would like to point out in this file is, as you can see, in front of all the basic pins, there's a V1, V2, V3 code written here. Now, this is basically the virtual pin which is generated by the Blynk Cloud application, which links both the Blynk mobile app to the Blynk Cloud, and this is the same virtual pin which lets us control the particular tool which you want to control. Let's say the heater, cooler, the inlet valve, etc. So basically, if temperature gauge is assigned V1 virtual pin, now the same virtual pin will be we need to configure in our Blynk IoT mobile application, which would then synchronize both of our actions, so that when we press the button of the temperature gauge here in our phone, which this would lead to the message being sent to the Arduino Uno that the user wants to access the temperature gauge, yes, etc. So let's. This is basically, for moving on. This is basically the serial tank code for the serial tank, and these are the header files for the serial tank. Similarly, it goes for the temperature sensor, and then again the header file for the temperature system. Okay. Now what I have done is I have verified or basically compiled this all of this code, and what it will do is it will generate the hex file and a binary file which will be stored in the folder of your project. I'll show you. Okay, so here is the latest binary file and the hex file which was created. I have already done it. So the binary file and hex file is created when I've compiled the code. Now what we have to do here is I'll we have used it as we know, as I have explained in the presentation earlier. We have used the PixSim lab, which is a simulation tool to simulate the Arduino Uno environment. Since this was a virtual internship, since we have to use the virtual part to show the working of the project. Now the Arduino Uno which we have model which we have used is the Atmega 328E model. All right, and these are all the spare parts which will be needed to show you the working of the project, which includes this. This is basically the LDR sensor, which will be used for showing the automatic turning on of the lights as the sunlight goes down for the down. Now this is the CLCD display. This is the Ethernet model, which is a W550 module, and this is the basically the temperature system, which includes the heater and the cooler. Now, I would like to show you the certain tweaks which I have made in the properties of each and every one, every system, so that you would get familiar with it. Here is certain changes which I have done. Okay, so moving on. Now, in order for the spare parts and the Arduino Uno to connect to each other and get synchronized properly, we can use emulator, which we call as null emulator. But for this, there's also alternative which we were taught by Ms. Jayalakshmi ma'am, that we can either use HSD virtual serial port tools. So what I've done is I have linked COM6 and COM7 together, so that there forms a local bridge between the two. Now, going back to this simulation, what I'll show you. What I've done is I have for the Uno, I have set the COM6 serial port for the Arduino Uno, and similarly I have set the COM7 Arduino Uno for the serial remote tank. Okay, serial remote tank, which will be used to denote the water flow, inflow and uh, outflow of the project. So I've taken the liberty and I have paired. I have powered I have mirrored my phone screen, and as you can see here. All right. So firstly, I would like to show you the garden light simulation here. So what this basically shows here is that since in the daylight there is no since there is already sunlight, there is no need for the lights to glow. But as the day goes by and the sun goes away and the light decreases, the garden light basically needs to automatically increase the brightness, and in the night they need to be in the maximum potential peak brightness, so that in this, so I'll show you in this bar. This shows that since the bar here is low, this shows that there is day and the sunlight is there, so there is no need of lights to glow. But as I slide the bar down, which will show that as the day goes by and at the top, that is when the night comes, this light, that is the light number one, needs to glow to its maximum brightness, which will show that as the day goes by, the light will automatically start. Okay, so I'll show you. All right, as you can see, as the day went by and night came, the LED shining the brightest, which shows that the project is working. One part of the project is working correctly. All right, moving on. This is the temperature system. So what I'll do is I'll show you my phone screen. Alright, so this is the interface which I have built in the Blynk IoT application in my phone, and each and every button has a particular virtual pin, which is first configured in the Blynk IoT cloud, as I have explained earlier in the video. earlier in the video. And when I press these are the push buttons. So as long as I hold the buttons, the message will be sent to the via the Blynk Cloud application to the Arduino Uno to perform the particular application. So as you can see here, the temperature is currently 27.34 degrees Celsius. Now what I'll do is I'll turn on the heater so that which will show that the temperature is increasing. All right. As you can see, the temperature here is increasing, and the heater turn on message is shown on the CLCD display. Now, the maximum temperature to which the heater would go is around 34ish to 35 degrees Celsius. Celsius. Now, what I've done is I have switched off the button, and as you can see, the heater is turned off. I'll show you again that the heater is on and the temperature increases. And after reaching the 35.16 degrees Celsius, which is the maximum temperature set here, the heater will turn off automatically. Now, what I'll do is I'll start the cooler so that which would show in the CLCD display that the temperature would decrease, and I would like you to see the fan here, which would start rotating, which would show that the cooler is also turned on. Alright, as you can see, the cooler is turned on, the temperature is decreasing as well as the fan is moving down, rotating. So as you can see, the cooler is off again and the temperature is back to 27.34 degrees Celsius. Once again, I'll show you. I've turned on the heater and the temperature is increasing. As you can see, the heater is turned on and the temperature will hit its maximum 35.16 degrees Celsius, and the heater will turn off automatically. The Ethernet module is continuously on by seen by the blinking light, which will show that this interface is continuously connected to the Blynk IoT cloud application, as well as my phone is connected to the same Wi-Fi network, which will show that this app is connected to the same cloud application. So basically, the Blynk cloud is acting as a connection interface between my phone and the Arduino Uno, and sending all the commands which I'm commands and signals of the command which I wish to be executed to the Arduino Uno for it to be executed. All right. Moving on. This is a simulation of the serial remote tank. The top one is the inlet from which the water comes into the tank, and the bottom one is the outlet from which the water goes out from the tank. Now, what if I will press the inlet valve button? The water starts coming into the inside the tank, and as you can see here, it's written that the inflow button valve is on, and the volume of the tank is shown here. The peak or the maximum volume of the tank is 3,000 liters. So after 3,000 liters, the inflow of the tank automatically turns off without me performing any command on it. Now, if I want the outlet valve to open and all the water to be drained, what I'll do is I'll press the outlet valve button on my phone. And as you can see in the CLCD display, the outflow or outlet valve buttons is shown that it's on, and the water level is increasing because the water is draining out. Now, what I've done here is the maximum the level to which the water can drop is 1960, and after that, automatically the inflow valve will start, and the water will start filling up again. Which ensures that the tank would never get empty and we would not have to suffer. Now, what I'll do again is I'll open the outlet valve again. Alright, my mistake. The inlet valve was on, so that's why the water was not draining. Now what I'll do is the outlet valve is on, and you can see the water is draining, and it's shown in the CLCD display. Now after hitting 1960, the inlet valve is start automatically without me pressing it, and then the water will start filling. And what I've done is I have stopped the inlet valve off, which can show that I can control this with my phone. Okay, I'll start it again, and it fills, and I'll stop it. So it's stopped. It's a bit laggy. Don't mind it. All right. So this was basically the working of the project, and I would like to thank Emertxe for this opportunity to for providing us with this internship, and we had gained I gained a lot of insights in the working of the IoT, and also the C and the C++ language which were taught by Ms. Jayalakshmi ma'am. I would like to thank Emertxe once again for this brilliant opportunity to. All right, that's it from me. Thank you.